Betelgeuse, or bug, is the name of the red monster star. Ju is a squirmy, almost eerie Jew in crimson. The Goliath star is one of the galaxy's marvels. If it were placed in the Sun, it would reach the ring of Jupiter. It is massive and very unstable, and it will explode, causing a catastrophe of unprecedented proportions. On the outskirts of our planet, the red Goliath star Betelgeuse is sending alarming signs. Using the James Webb Space Telescope, astronomers have received signals from space and found something really important. Renowned physicist Brian Cox has issued a dire warning about this repulsive star. The question that never goes away is if we will see a burst from a cosmic explosion that will change the night sky till the very end. The link between the infinite number of stars in the universe and the Beetlejuice problem of time is that stars are born and, more recently, die in startling ways. One star has caused worry among both space experts and the general public: the red supergiant Betelgeuse. The heavenly bodies of Orion. As we learn more about Beetlejuice, we're getting closer to a potentially amazing event in its history, but what could these changes affect in Beetlejuice? Are we seeing the beginning of an endless scene on an unfathomably enormous scale? The Goliath star is truly terrifying in archaic times, with its unique rosy diversity and erratic splendor having been enchanting. However, recent events have raised awareness of this massive star. This incredible beginning only serves to highlight the true loftiness of Beetlejuice, as it not only displays its stage in the life cycle of heaven but also reveals its nature as a crimson Goliath star. Betelgeuse's enormous size and life cycle turned it into a heavenly Goliath. It was roughly 10 times larger than our Sun, just beyond human comprehension to imagine a star so terrible that if it replaced our Sun, its surface would extend beyond Venus and Mercury, even within the Mars surface cycle. After using up all of the hydrogen at its core and combining helium, Betelgeuse is nearing its cooling and prolonging finish. This star is thought to be between 8 and 8.5 million years old, which is young in stellar terms but old in heavenly terms. From a dazzling blue star to the red Goliath we see today, Betelgeuse has undergone emotional changes and is now nearing the end of its existence as a crimson Goliath star. Because of the constant atomic combination tensions in gravity, stars change with time. This is why Betelgeuse has a distinct rosy hue that emerges from its relatively low surface temperature in comparison to stars like our Sun. Betelgeuse's surface is around 3,500 Kelvin, while the Sun's surface is 5,500 Kelvin, according to reliable records and changes. This lower temperature allows Betelgeuse to emit light at frequencies that give it a crimson appearance, but this tone goes beyond appearances. It tells us about the physical state of the star and the cycles occurring inside its massive vaporous body. Historical records from Roman and Chinese history show that Betelgeuse were yellow approximately 1,000 years ago, and 9th century Arabic cosmologists observed that they had changed from their red variety over the course of human history. These verifiable remarks suggest the development of the star. Additionally, Betelgeuse's brilliance is evolving. Because Betelgeuse is a semi-regular variable star, its brightness varies periodically. For hundreds of years, astronomers and scientists have been awed by its fading and brightening. Betelgeuse often go through cycles of a few days and a lengthier 5-year span. In 1836, Sir John Herschel made note of these cycles. There may be much more history in the Native American chronicles. What really makes Betelgeuse unique is not only its ever-changing beauty but also the fact that it is unlike many stars whose brightness varies often. When Betelgeuse sometimes deviates from this pattern, it indicates complex and poorly understood processes inside its massive structure. Astronomers were shocked to see a dramatic and noteworthy change in Betelgeuse's appearance lately. By 2019, one of the brightest stars in the night sky, Betelgeuse, had begun to mysteriously fade. It was dimming so quickly that it started losing light at an average rate of 0.01 magnitudes per day. By February 2020, it reached its peak dimness, creating difficulties for observations of Betelgeuse that are normally visible to the naked eye, even in areas with significant light pollution. This mysterious fading sparked a number of theories with input that are currently recognized as pointing to a remarkable decline. Witnesses see the difference, but since light takes so long to reach us, it is difficult to witness Betelgeuse activities because we are really seeing the star in its previous state. As part of a 3-year study using the Hubble Space Telescope, researcher Andrea Dupree, the center's deputy director at Harvard and Smithsonian Astrophysics, and her team closely monitored Betelgeuse because Betelgeuse's light takes about 725 years to reach us, making it challenging to predict or observe swift changes in its behavior. Their findings demonstrated how Betelgeuse's vast atmosphere and surface vary and offered new insights on how they operate. As Betelgeuse dimming raises concerns, their investigations showed debris traveling at a speed of around 200,000 miles per hour from the surface of Betelgeuse into its atmosphere. According to one explanation, a mass ejection from the southern hemisphere of the star produced a dust cloud that covered a portion of the star's surface. This mass ejection was especially noteworthy since it occurred faster than earlier star measurements. The future of Betelgeuse is yet unknown. Is this a one-time occurrence in the star's long and intricate existence, or might it be a portent of an impending cosmic explosion? Some hypotheses contend that Betelgeuse fading is caused by dust clouds formed by its material ejections, while others look at whether variations in its outer layers are affecting its visibility. Whether or not Betelgeuse explodes in the near future, its destiny might provide fresh perspectives on the life cycle of big stars. As the star continues to evolve, it provides a unique chance to investigate the universe's most dramatic processes. As the crimson giant Betelgeuse nears the end of its life, scientists and stargazers alike are closely monitoring the impact of cosmic explosions and interstellar media on star formation. While Betelgeuse's surface temperature is lower than the Sun's, giving it its distinctive red hue, the possibility that this enormous star would explode in a supernova is both a fascinating event and an important area of study. There is a lot of conjecture over its impending death due to the variations in its brightness. According to recent studies, Betelgeuse is losing mass at an accelerated rate, spewing enormous quantities of material into space in the form of dust clouds that block off light and make the star invisible. Astronomers have conducted a great deal of research on Chang and Betelgeuse behavior using both ground-based telescopes and space-based observatories, such as the James Webb Space Telescope, JWST. JWST has given scientists previously unheard-of insights into the processes taking place in Betelgeuse's outer layers, capturing the complex dynamics of stellar winds and mass loss. This new information has contributed to a better understanding of the evolution and demise of huge stars such as Betelgeuse. Among the most intriguing features of Betelgeuse's potential, the supernova's closeness to Earth. When Betelgeuse finally explodes as a supernova, the light from the explosion will be so bright that it could outshine the full moon for weeks or even months. The night sky will be temporarily altered, and scientists will have a unique opportunity to observe the death throes of a massive star in real time. At about 725 light-years away, it's close enough to give a front-row seat to one of the universe's most dramatic spectacles without endangering our planet. Additionally, Betelgeuse supernova may have profound effects on our comprehension of stellar evolution and the part that large stars play in the creation of heavy metals. The heavy elements created by Betelgeuse's explosion would be dispersed throughout space, enriching the interstellar medium and aiding in the formation of new stars and planetary systems. Supernovae are responsible for the creation and dispersal of elements like iron, nickel, and oxygen, which are essential for the formation of planets and life. Understanding the life cycle of a single star is only one aspect of studying Betelgeuse. Another is discovering the mysteries of the cosmos. Every new discovery aids scientists in improving their models of stellar evolution and forecasting the future of other massive stars. As Betelgeuse continue their gradual demise, knowledge of how stars like them die provides insight into the processes that have created the universe for billions of years. The question on everyone's mind remains, when will it explode? While scientists can't say for certain, they believe that it could happen at any time within the next 100,000 years. A blink of an eye in cosmic terms. Until that day comes, we will continue to watch, wait, and learn from this extraordinary star. In the meantime, the excitement surrounding Betelgeuse serves as a reminder of the incredible power and beauty of the universe. Whether the star explodes in our lifetime or not, The mystery and wonder it inspires will continue to captivate us for generations to come. The anticipation surrounding Betelgeuse's fate grows as astronomers eagerly watch for signs of an impending supernova. While the exact timing remains uncertain, the giant star's erratic behavior has intensified speculation. Its mass loss and dimming, particularly since 2019, suggest that dramatic changes are underway. If Betelgeuse does explode within our lifetime, it would be a once-in,